meal, the longer the food will stay here for digestion. What do you think the stomach is built for?
Storing food.
So, yeah, food storage. Do you know how big the stomach can expand to be?
1 liter, 1 gallon.
About a gallon. That is huge, isn't it? Think about eating a gallon of food. Put a gallon of food on your plate and think, I'm going to put that in my stomach. That is tremendous, isn't it? And of course, there's muscle layers that will stretch to accommodate whatever we put in there. So if you constantly eat large meals, the stomach will expand to accommodate those large meals. If you constantly eat small food meals, then of course it will shrink to accommodate those smaller meals. But you're right, basically it's a food storage tank, and what we're going to do here is dump a bunch of acid and enzymes to help start the digestion of food. Let's do the anatomy first. At the bottom of 92, let's talk about the anatomy. Okay.
In the sphincter and the cardiac sphincter, is there anything mechanical going on there in those?
Not with the sphincters, no. It's just a doorway to pass through. Yeah.
Closes back up.
Closes back up, exactly.
The pressure basically opens.
It is a pressure regulator. Coming down from the esophagus, I'm glad you brought up the sphincter there, so we'll go ahead and cover that one first. There is a sphincter that you pass through here. It serves as a division between your esophagus and your stomach, but it is not the bottom line for division. The absolute bottom line for division is the tissue transition, because stratified squamous lines your esophagus, simple columnar lines your stomach. This is where we say, draw the line right here. That's the division point. So when you look at something like this, and you say, well, there's the sphincter, that must be the esophagus. Unless it's lined with stratified squamous, it's actually technically still what? The stomach, yeah. So the transition is technically ruled by what type of tissue you have between those organs. These sphincters are created by the rings of circular muscle in the muscularis externa layer. They are pressure regulated. They normally stay closed. So if a sphincter is closed, the only way to open it is put pressure on it. So when food is sitting on top of the sphincter, it opens up and lets the food slide through. After that point, it goes back closed again. It works both ways. If you vomit, of course, pressure on the bottom side of that sphincter will also cause it to open, letting food travel back up into the esophagus. We've actually got two sphincters that regulate the openings of the stomach. We've got this cardiac sphincter up here between esophagus and stomach. We've got pyloric sphincter between stomach and what?
Small intestine.
Small intestine, good. There are a number of names for the cardiac sphincter. In addition to cardiac sphincter, you'll notice it's called lower esophageal sphincter because the upper one is up here at the top of your esophagus. They'll oftentimes call this the LES for short because it is, abbreviating for the lower esophageal sphincter.
So what's with the O?
I don't know, it must be somebody's fancy spelling there. I don't know what. It was a good picture, so I thought, well, I'll grab it anyway, but I don't know what the O is for. Alright, so where's the cardia or cardiac region?
Near the cardiac sphincter.
Good. Near the cardiac sphincter right here in this region. Cardiac implies you're closest to the heart. This J shape actually scooches over toward the left side of your abdominopelvic cavity. The apex of your heart also sits oriented in that direction. That's why sometimes people have acid stomach or GERD and think they're having heart problems when in fact it is just this portion of the stomach that's giving them trouble. Always wise to have it checked because you never know which it really is. What is the region that extends over this way? Fundus. Good. The main portion is called the body, and this region? Pylorus. Good. We got 4 main regions of the stomach. Of those 4, where do you think the most digestion is occurring? Body. And pylorus. You can see the natural orientation here. The food naturally just slides down here toward the pylorus region. So the pylorus in the body is where most of that digestive activity is going to occur. Okay. On your worksheet, I want you to notice something down at the very bottom of page 92. Notice for the pylorus, in that region, we have many glands that secrete things like mucus, gastric juices, hormones like gastrin. So the big time activity is funneling that food down there where it's closest to the small intestine. All right, let's flip over to the top of page 93. How about questions so far?
What do you do about the pH that leaves the stomach?
You mean the acid stuff? Going to the small intestine, we're going to neutralize it with pancreatic juice.
Okay.
Yeah, that's a very good question.
Which tissue was on that line of stomach?
Say that again.
Which tissue line of stomach?
The tissue in the stomach is simple columnar, this stuff here, and the tissue inside your esophagus is stratified squamous. And that is the division line between those two tissue types.
It's neutralized with pancreatic juice before it gets to the small intestine.
Once it's in the small intestine. Have you cut a cat's stomach open? Kind of weird, isn't it? Looks like a wrinkly brain in there. What is this lion called? Reggae. Always reminds me of reggae, but you know, that wrinkly mucus moist membrane that lines the stomach. When do you see the reggae? When you're full or when you're empty? Empty. When you're full, the stomach expands to hold food, so of course the reggae is less obvious then. But when you're empty, that reggae kind of is the folds of the stomach collapsing in on itself. When you're hungry, and we start talking about food again, let me see, we can talk about fried chicken and mashed potatoes and gravy. We can talk about chocolate cake and ice cream. By the time you leave here, I guarantee you your stomach's going to be growling, even if you're not normally hungry at this time of the morning. Part of that is just the mental suggestion of food. The other portion is tasting it or smelling it. So any of those activities will actually trigger your mouth to create saliva and your stomach to start secreting gastric juices. If you've got air in the stomach and gastric juice is present, the rugae are going to start grinding in there with peristalsis. It's thinking, oh, some food's coming down, even though you're just thinking about it or smelling it. But it's preparing the stomach for the activity that may come. So if you have a growling tummy, it's the emptiness combined with the air and the juices inside the stomach. So you're a tidbit of trivia for the day. Alright, let's take a look inside of the stomach. You notice all of that mucous membrane is lined with simple columnar epithelial tissue. Inside your stomach, we have these deep pits called gastric pits. Okay, so on page 93, I am about third of the page down where it says microscopic structures. And this information starts in your textbook on 768 and 769.
Is your stomach ever completely empty?
Yeah, if you get up in the morning, it's completely empty then. Yeah. Alright, let's hit those microscopic cells. Most of what you're looking at here is simple columnar epithelial tissue, but there's a set of specialized cells embedded within this tissue. So let's hit the first one. They're called a mucous neck cell. As you would expect, a mucous neck cell is going to secrete mucus. Notice this mucus tends to be acidic, so it has a twofold function. Partly the job of that mucus is to help protect the lining of the stomach. The acid is also necessary for helping to break down certain food groups, proteins especially. So the mucous neck cells do secrete acid mucus.